The story of the discovery of punctum began in a rather ordinary way. While analyzing data on active regions of the distant galaxy NGC 4945, radio astronomers suddenly noticed a strange, bright, and unusually stable spot of millimeter radiation. It did not resemble any known source. The signal did not flicker, did not intensify, did not weaken. It remained perfectly steady. Such behavior is absolutely uncharacteristic for space, where everything is subject to fluctuations and chaos. That is precisely why the object was named punctum. The main anomaly was that in the optical range, there was nothing at its location, no faint star, no dust cluster, no traces of a supernova. In the X-ray range, there was complete silence as well. And only radio telescopes could see it so clearly, as if it deliberately chose a single range to communicate with the universe. Scientists checked archival observations and, to their surprise, discovered that the object had existed for many years. It simply hadn't been noticed before. It didn't fit any search algorithm. For science, this was a blow. How could something so bright and unusual have been missed? From that moment, it became clear we were dealing with a new phenomenon that has yet to be named in textbooks. That's when the first big question arose. If it's not a supernova remnant and not an active galactic nucleus, then what is it? The answer still seemed out of reach, but scientists already understood that this was no coincidence. This was a signal, and there was something more behind it. Punctum immediately became the subject of heated debate. Space rarely throws such surprises our way. Usually everything can be classified: supernovae, pulsars, magnetars, quasars. But punctum didn't fit into any of these categories. It was as if it deliberately broke the rules. The most astonishing thing was that its radiation was perfectly stable. Absolute stability doesn't exist in nature. Even neutron stars, with their precise pulsations, tremble ever so slightly. But punctum behaved as if it operated according to a precise algorithm. Some scientists cautiously noted that such behavior was more reminiscent of an artificial source. Of course, such assumptions are not discussed officially, but the very idea of a cosmic beacon has seeped into articles and commentaries. Most researchers, however, lean toward the idea of a new class of astrophysical objects, but exactly what kind remained a mystery. The energy output was of particular interest. Punctum is not only stable, but also exceptionally bright in its range. This means that some process inside it is keeping the energy within very narrow limits. What is this process? No one could say yet. This phenomenon shattered familiar frameworks, which meant that something more was at stake than just another galactic oddity. Punctum became a challenge to the very idea that the universe is governed by clear and comprehensible laws. The next step in studying the object turned out to be even more intriguing. When the polarization of radio waves was studied, it became clear. The punctum signal is not chaotic, it is strictly structured, which indicates the existence of an extremely powerful magnetic field. Moreover, the field is not just strong, it is extraordinarily well ordered. This is an extremely rare phenomenon in astronomy. For comparison, magnetars are the most powerful magnetic objects in the universe, but their fields are wild and unstable. Here, however, an almost perfect structure is observed. It seems as if punctum maintains a magnetic order within itself that does not break down over time. This discovery turned the entire discussion upside down. It became clear that we are dealing with more than just a strange source of radio signals. We are dealing with physics that we do not yet understand. Some researchers began to talk about a new category of compact objects, standing apart from everything known. Perhaps this is some kind of transitional stage between magnetars and black holes, or maybe it is something entirely different, a new class of celestial bodies. The most frightening thing is that if punctum is not unique, then there could be hundreds of similar objects in the universe and we simply do not see them. While some scientists were puzzling over the nature of punctum, others stumbled upon a colossus that is even more astonishing. At the center of a gravitational lens known as the cosmic horseshoe, they discovered a black hole with a mass exceeding 30 billion solar masses. This is one of the most massive black holes ever measured. Its size goes beyond what we are used to. Even the largest black holes at the centers of galaxies rarely reach tens of billions of solar masses. This object seems to be testing the limits of physics itself. Theories claim that black holes have a natural maximum mass, but the horseshoe shows something different. How could it have grown to such proportions? There are several hypotheses. Perhaps it formed as a result of multiple mergers of other black holes, or over billions of years it absorbed matter at an unimaginable rate. But none of the explanations seem convincing so far. Scientists realize that if such a black hole exists, the laws governing the growth of galaxies will have to be rewritten. This colossus is the key to understanding just how flexible the boundaries of the cosmos can be. When the mass of the colossus from the cosmic horseshoe was confirmed by independent methods, a real debate erupted in the scientific community. According to models, a black hole cannot grow endlessly. There is a limit, a kind of ceiling, after which gravity and the laws of accretion should halt the process. But observations have shown that this limit is not so clear-cut. If the black hole has indeed reached 30 billion solar masses, then it has come right up to the theoretical boundary. But what if it manages to exceed it? That would be a blow to all existing models. Some astrophysicists cautiously suggest that we might encounter even more massive objects. We just haven't found them yet. Such a discovery changes our understanding not only of black holes, but of the structure of the universe as a whole. After all, if physics allows for such exceptions, then much of what we considered solid truth may turn out to be just a temporary assumption. And while debates about these colossi were gaining momentum, new discoveries once again turned the picture upside down. A strange object appeared on the horizon, standing between two worlds, neutron stars and black holes. In August 2019, the LIGO and Virgo gravitational wave detectors registered an event that made history. At first, it seemed like an ordinary merger, a massive black hole of over 20 solar masses swallowing its smaller companion. But when the details became known, it was clear this was a phenomenon. The second object had a mass of about 2.5 solar masses. This number turned out to be critical. No neutron star can be that heavy. Its matter would simply have collapsed inward under its own gravity. But a black hole with such a small mass has never been observed either. This created a paradox. The object is too massive to be a neutron star and too light to be a black hole. It was called a body from the forbidden zone. Scientists are still debating what it was. Some believe that this is indeed a record-breakingly heavy neutron star. Others are convinced that we are dealing with a new type of compact object, which will have to be classified in a separate category. And the most interesting thing is that this is not an isolated case, but merely the first discovered representative of an unknown class of objects. For many years, there was a clear distinction. Neutron stars exist up to a certain mass, and beyond that, there are only black holes. But the new discovery has shattered this neat scheme. Some scientists have tried to explain the object using exotic forms of matter. There is a hypothesis about so-called quark stars, objects where matter is so compressed that neutrons break down into quarks. Such stars can be heavier than ordinary neutron stars, but still not collapse into a black hole. Other researchers have suggested that we are witnessing for the first time a transitional state where a neutron star is literally on the verge of turning into a black hole. But no matter how this event is interpreted, the fact remains, we will have to reconsider the fundamentals of astrophysics. Astronomers are now carefully studying all gravitational wave data to find similar examples. If such cases are found, our picture of the universe will become even more complicated than we thought. While some were puzzling over the mystery of the object between worlds, other telescopes discovered a monster of a different kind. The quasar turned out to be so bright that it outshines 1 billion suns. Its central black hole is growing at a terrifying rate. It consumes a mass equivalent to our sun in just one day. To grasp the scale, our sun burns its fuel slowly, living for billions of years. But this black hole devours the same amount of mass in just 24 hours. None of the known models of accretion, the process of matter falling into a black hole, can explain such an insane appetite. According to calculations, at such a high growth rate, the luminous matter should actually slow down the infall. But that doesn't happen. Scientists have called this object a true rage machine. Its light can be seen from enormous distances, and its energy is so monstrous that it can influence the formation of entire galaxies around it. This quasar has become a new mystery. If it is not unique, then perhaps there are other such insatiable devourers in the universe. The main question posed by the quasar is simple. How can a black hole grow so quickly? According to modern theories, accretion is limited. When matter falls into a black hole, it heats up and begins to glow. This light creates pressure that should stop further infall of matter. This is called the Eddington limit. Astronomers are debating, could it be that we misunderstand the interaction between matter and radiation? Or is there a special accretion mode in which a black hole can literally break through the ceiling? If that's the case, then supermassive black holes could form much faster than we thought. It may have been precisely these processes that created the giant colossi in the early universe. And if that's true, we'll have to rewrite the history of cosmic evolution. And just when it seemed the universe had already presented enough mysteries, yet another anomaly appeared on the scene. A black hole behaves as if it has a heart. It emits X-rays in rhythmic pulses, as if in sync with the heartbeat of a living organism. Scientists observed its light intensifying and fading with astonishing regularity. These are not random fluctuations or chaotic bursts typical of accretion disks. Here, we're talking about a distinct rhythm. No one understands what could be causing such a phenomenon. One hypothesis suggests it's a peculiar oscillation of hot plasma orbiting around the event horizon. Another theory proposes that we are witnessing an entirely new type of instability in accretion disks. In any case, a black hole that pulses sounds like a challenge to everything we know about the cosmos. This rhythm has become a symbol that even the darkest objects in the universe can conceal mysteries that make physics resonate in a whole new way. The pulsations repeated with such precision that some researchers compared them to musical resonance. It turned out that the accretion disk around the black hole behaves like a giant drum where plasma begins to oscillate according to complex laws. But no one knows where this precision comes from. These rhythms are not just a beautiful metaphor. They make physicists wonder whether there might be mechanisms at work near the event horizon that we know nothing about. After all, ordinary matter shouldn't play in such harmony. Some hypotheses suggest that it is precisely in these rhythmic processes that the keys to understanding the quantum nature of gravity are hidden. For astronomers, this served as a reminder. Even things that seemed long studied, black holes, their disks, their radiation, can unexpectedly reveal themselves from a different angle. After a series of discoveries, scientists began to ask an uncomfortable question. What if such objects are more common than we think? After all, the punctum was discovered by accident. At first, the quasar also looked like an ordinary bright point. It's possible that dozens of similar anomalies are already hidden in telescope data. We just don't know how to identify them yet. Some experts cautiously point out that scientific publications are often delayed or don't reveal the full picture. Not every strange observation immediately becomes a sensation. Sometimes data sits in archives for years until someone accidentally notices an unusual detail. And then another discovery surfaces, once again shattering our familiar frameworks. This secrecy creates the impression that the universe is far stranger and more diverse than official reports suggest, and perhaps we are only at the very beginning of a long journey to understand it. Our theories are convenient, but time and again, nature proves that its laws are far more complex than the diagrams in textbooks. Physicists like to think that the universe has limits of mass, speed, energy, but reality shows the opposite every time. It's as if the cosmos is deliberately challenging us. And while we argue about models and boundaries, somewhere out there at the edge of the visible world, processes are taking place that don't fit into any formulas. As we finish this journey, we are left with the feeling that the universe is more like a living being than a soulless mechanism. It pulses, shines, breaks its own rules, and builds them anew. And perhaps it is in these very paradoxes that the main answer is hidden, the knowledge that for now we understand almost nothing.